Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 4. This is Section 11.2, problem number 4. It says, consider the function f of x equals x minus 9 when the input is greater than or equal to 2, and f of x equals 2x plus 1 when the input is less than 2, or x is less than 2. And we want to determine if this function is continuous when x equals 2, and also if the function is continuous when x equals 6. So again, to determine if a function is continuous at any given point, you have to answer the same 3 questions that we always answer. So first, does f of 2 exist? And again, 2 because the question says, see if it's continuous at 2. The question is, can I put in a 2 in this function as an input and find an output? Well, based on the 2 branches of the function, when I put in a 2, I have to use the top branch. The top branch says if my input is 2 or greater, use this top branch. And this is use the bottom branch only for input values that are less than 2. So to put in a 2, I must use the top branch. And I put in a 2 for x, it becomes 2 minus 9, which is negative 7. So does f of 2 exist? F of 2 equals negative 7. The answer is yes, f of 2 does exist. Now, does the limit of f of x as the input approaches 2 exist? That's the second question you have to ask yourself. Now, at 2, to find the limit, I have to use both the top branch and the bottom branch. Again, for a limit, I'm not actually putting in a 2. What I want to see is what's happening as I put in values that are super close to 2, like 1.9, 1.99, 2.1, 2.01, 2.001. So for the values, input values slightly larger than 2, like 2.001, I want to see what's happening with the top branch. And I can tell from the first question, as I put in values just a tiny bit bigger than 2 as input values, the output values will get really, really close to negative 7, what I was getting when I actually put in the 2. Now, the bottom branch, as I put in input values super close to 2 that are slightly less, like 1.999, what's going to happen is I'm going to get 2 times x plus 1 becomes 2 times 2 plus 1, or 4 plus 1. I'm going to get a 5. So in the top branch, when I put in values super close to 2, I'm getting a negative 7 as the output. The bottom branch, as I put in values super close to 2, I'm getting a positive 5 as an output. 2 different things. So the limit does not exist. So I don't even have to consider question number 3. I can say this function is not continuous when x equals 2. Because the limit doesn't exist at 2. Now, part B, is f of x continuous when x equals 6? So we have to answer the same 3 questions. Can I put in a 6 and get the answer? Can I take the limit as x approaches 6? And are those 2 answers about the same? So first of all, can I put in a 6 as an input value? So now as I'm putting in a 6, I'm going to use strictly the top branch. I'm using an input that's larger than 2. 6 is larger than 2. So I can get rid of this from part A. So if I put in a 6, I get x minus 9 becomes 6 minus 9, which would be negative 3. So I can put in a 6. So f of 6 equals negative 3. Can I take the limit as the input gets really close to 6? Again, like 5.999 and 6.0001. Well, both the values a little smaller and a little bigger would be dealt with in the top branch. And as I put in values super close to 6, the output is still going to get super close to negative 3. So the limit as x approaches 6 for this function also equals negative 3, which means the answer to the third question is going to be yes. Does the value of f of 6 equal the limit of f as x approaches 6? Yeah, they're both negative 3. So I got a yes on all 3 questions, which would tell me that this function is continuous when x equals 6. Is continuous. So again, for part A, the function is not continuous when x equals 2, because the limit does not exist. But it is continuous when x equals 6, because I got a yes to all 3 of the questions I have to ask when I determine if a function is continuous at a point.